Alrighty, we are going to talk about the product rule and quotient rules. We have one more thing after this, and then we'll have hit all of our big derivative topics. Every other derivative topic will be based on, or will use the rules we've already talked about. Okay, so product rule means we're multiplying things. Here, let me get to my right screen. Here we go. We're multiplying things. So if we have two functions, f and g, they're both differentiable. Then the derivative of those is we take the derivative of the first times the second as is, plus the first times the derivative of the second. You can think of this as f prime g plus f g prime. Some books reverse the order of this a little bit. Since you're adding, it doesn't matter. I always choose to present it in this order because then it's going to match the quotient rule better when we go down, when we get there. I'd rather have them be similar than completely different, because personally that confuses me. But as always, use what works for you. So sometimes it helps to separate these out and kind of say, here's f, here's g. So I'm going to do this. I'll do them all a couple ways. So I'm going to say this is my f function and this is my g function. So f of x equals 3x minus 2x squared. F prime of x, take the derivative of that. So I get 3 minus, bring this down, 4x. Then I find my g and its derivative, 5 plus 4x, g prime of x equals 4. All right, so now we can kind of plug it in our equation. You can say y prime equals the derivative of the first thing, 3 minus 4x, times the second thing plain as is, plus the first thing as it was, 3x minus 2x squared, times the derivative of the second, which is just 4. At this point, you want to clean up a little bit. I'm not going to worry about that. I know we can do that by now. I'm going to focus on the more calculus parts. So we're done. We have, this is our f prime, our g, and this is our f and g prime. So the more complicated problems, I'll kind of write the functions off to the side. The more straightforward ones, I tend to just do them in line. So this would be one I would probably do in line because the derivatives are relatively straightforward to where some of the other ones aren't. There's one coming down that we will definitely want to break into pieces a little more. Oh, I didn't give myself much space. That's okay. Okay. So this time our function's already labeled f of x. So I just think of it as first, second, first, second. And this guy, actually, you know what? Let me rewrite this. It's easier to take the derivative of 1 over x if we turn it into x to the negative 1. So I'm going to do that. All right, f prime of x. Take the derivative of the first. So bring this down. I get negative x to the negative 2. Derivative of the second, or the derivative of 1 is 1, rather. That's what I'm trying to say. Times the second thing. Plus the first thing as it was written. Times the derivative of the second, which is just 1. So that's that. That one's done. You probably want to clean this up a little bit by, here, we'll do one cleanup stage. And this turns into negative parentheses x minus 1 over x squared, plus that is just 1 over x plus 1. You might want common denominators, but I'm going to leave it for the same reason I left the others. We're good. Okay. We're going to take the derivative of two things. So f is going to be blue, g will be pink. Notice they're very similar. there's a couple ways we can tackle this one. We could distribute first on both of them. I'm going to choose not to. I'm going to do the product rule on both of these. Oh man, my computers are loud today. Okay, so for f, I take the derivative of the first, which is derivative of 2x is just 2. Oh, my pen is also going crazy. There we go. Times the second, as is, plus the first, whoops, times the derivative of the second, which will give me 2x plus 3. Again, I can do some cleanup, but I'm going to choose to leave it there for now. Just give me pink, thanks. All right, G is going to be in pink. I'm going to bring it down here. Okay, this is my first thing. This is my second thing. The derivative of a constant is 0. So the derivative of the first times the second plus the first times the derivative of the second, which is, again, 2x plus 3. This one I am going to simplify a step because that goes away. I get 2 times 2x plus 3. So these are very different. The 2x versus just a 2 makes a big difference here. So one has a variable, the other is a constant. We could have dealt with g of x a bunch of different ways instead of doing what we did, but we wanted to see how they were different. So really this illustrates that when you have a constant, you're still technically using the power or the product rule. We just don't think of it like that because the derivative of a constant is 0. It just kind of cancels off. So be careful on these guys. All right, my last one for product rule is this monster. You have a lot of ways you can tackle this. In the book, there's a formula for dealing with 3, but personally, I'm not a memorize the formula sort. So I'm going to use the same rules, but I'm going to have to do it twice. So I'm going to block these off. This is going to be my f function. And this is going to be, whoops, let's go up here, my g. And now my f prime, actually, let's just write our f first. And remember, we want f prime g plus f g prime. So I'm going to temporarily pull out the f function. I'm going to find its derivative. We have to use product rule here. Okay. I'm going to do this in line because we already have enough things floating around. We don't need more. So derivative of the first is 2x times the second plus the first, x squared plus 1, times the derivative of the second, which is just 8. I am going to clean this up to make it look a little bit nicer. How do I want to clean it? I'm going, we'll do this. You know what? No, let's back up. I'll be less lazy. All right, distribute. I get 16x squared minus 6x plus 8x squared plus 8, right? Yep. Which equals 24x squared minus 6x plus 8. And that's just going to make our function a little nicer. Okay. Now I have this. Use our original formula. So y prime. Derivative of the first, which is just 24x squared minus 6x plus 8 times our second times our g function as is plus the first. I'm going to go back and write my original f function. I'm going to kind of block that off. Times the derivative of the second, which is our g. So I get 3x squared minus 1. So this f prime g, f g prime. So the more complicated the problem, the more cleanup or simplification you want to do early on. The simple problems, one that just have two things, I typically just attack them right away. Anything that gets a little crazy, I try to reduce it into fewer things. This method will get a lot easier the more you practice, as most things do. But just don't be afraid of these, break it into little chunks, attack it. And if way one doesn't work, try something else. It's helpful to know multiple ways how to do these problems because some problems are great way one, some are great way two, some are just terrible all around, and that's that. Sorry, it's coffee o'clock at my house. Okay. The quotient rule. You can take quotient rule problems and turn them into product rule problems if you want. I will show you how to do that on a couple of these. But knowing the quotient rule itself is useful just because it pops up sometimes. It's sometimes quicker to do this than to manipulate first, just depends on the problem. So we have two functions, f and g, they're both differentiable, and g cannot be 0. Excuse me, because if you divide by 0, it blows up. So we take the derivative of f over g. We have the derivative of f times g as is minus f as is times the derivative of g all over g squared. And so compare this to our product rule, which was f prime g plus f g prime. This is the same direction, f prime's first, then g, except this thing turns into a minus for the quotient rule. This is why I present my product rule in the way so it matches. You don't have to rethink, well, product rule, we have to switch f and g. Nope, always the same. I like things to be the same. All right. I should be able to do this two different ways. Let's do the actual quotient rule as is, and then we'll turn this into a product rule. All right, screen. I'll leave the formula right there. So y prime equals the derivative of the top. You can think of this as top and bottom too, is 1 times the bottom minus the top times the derivative of the bottom, which is just 2, all over the bottom squared. All right, I will clean this up a step. Probably 2 steps. Minus 2x plus 2 all over the bottom. Is that right? Yep. Which is just going to give me 5 over 2x plus 3 squared, hopefully. Yeah, looks good. All right. So that's how we do this with the quotient rule. It's fairly straightforward. It's not terrible. Of course, it can get terrible. Anything can get terrible. The way we can do this with the product rule. Now, you don't have to do these two different ways. I just want to show with one problem how they're similar and different. I'm going to rewrite my problem. Do this one in blue. This turned into x. Oh, actually, you know what? We can't do this yet. This requires a rule we don't have. So never mind. This requires the chain rule, and I forget about that. So we will do that in the next section, I think. Yep. It's something called the chain rule, so we can deal with that a little bit easier. But for now, that's what we got. Sorry. How many more did I write when I was? Oh, I did. Yay, go me. I wrote when I was done. Okay. Find the equation of a tangent line to f of x at the point 1, -1. It's underneath my little screen thing. So first things first, we find a derivative. All right. The derivative of the top is 4x minus 4 times the bottom as is minus the top as is times the derivative of the bottom, which is just -3, all over the bottom squared. So that's my derivative. It's kind of gross. We'll leave it there. We can always clean up more, or we can always leave it. Sometimes cleaning up is good, sometimes leaving it is good. In this case, I'm going to plug stuff in, so I'm just going to leave it. So that is our slope. So we're going to use y minus y1 equals mx minus x1. All right, so we're given a point and we have a slope equation. We can find the tangent line. What I want to do is take my x value and plug it into my derivative. So I'm going to say f prime of 1 equals, I'm going to do a little simplification as I go. So 4 times 1 is 4, minus 4. 2 times 3 times 1 is 3, minus 2 times 1 squared, 4 times 1, all over 2 minus 3 squared. So I've just plugged in 1. In most cases, it makes things just plain go away. It makes it nice. Clean up a little bit. That looks terrible. Try again. This is 0, so it cancels the first one out. And I'm going to get 2 minus 4 is -2, plus 3 is 1. So I get -1, right? 5 minus 4 is +1. Oh, I see what I was trying to do. Too many things at once. All right, 2 minus 3 is -1 squared. -1 times -3 is +3. -1 squared is 1. So we just get 3. Awesome. Change my color again. Now I have a slope and I have a point. I can find my tangent line. Y minus my y1 is -1. So I'm getting that from the point they gave us. M is 3. X minus my x1 is 1. Clean up. Subtract 1 from both sides. Can I? I want to fit this all on the same screen. Oh, I can't. Clean up. And as long as my math is solid and it looks okay, I get y equals 3x minus 4. This last step, the tangent line, you do want to clean up into the format I have, just because it's easiest to graph, it's most common, and it looks nicest. So middle of the problem, don't clean up unless it makes your problem easier. At the end, yeah, present your answer in a nice format, if at all possible. All right, so that's the equation of a tangent line. I have more space. The last bit is I found one that looked kind of gross. Honestly, any of these that are kind of messy looking, I clean them up first and then I do the derivative. I want the derivative step to be as simple as possible. Let's go to buy. All right, so 1 over x is like saying x to the negative 1 all over x plus 5. All right, the derivative of the top, negative x to the negative 1 turns into positive x to the negative 2 times the bottom minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. This is a yucky problem, but that's okay. All right, bring my negative exponents down. Minus parentheses 3 minus 1 over x all over x plus 5 squared. I could clean up a little more, but my negative exponents are gone. I'm going to leave it there. It's kind of a disaster of a fraction, but that's okay. Okay, that is the end of chain, or not chain rule, product rule and quotient rule. If you need more practice, the book has some great problems. Some of the things I've linked will give you some more as well. One piece at a time. If you need to separate them out into F and G's, take the derivatives first. That is a great first way to learn how to do these. And eventually they become a little easier. So I'm going to leave it there and then we'll move on to the next one.